Hey guys, what's up, people? Welcome back. How are you guys feeling today? Another what? Another how many more hours now for the new year to for the year to end? 2020 is about to come to an end. So how are you people feeling about that? All good? Yes. Good evening, everyone. I am awesome. Thanks a lot for asking. How are you people doing? What is up, people? What is up after a long time? Oh, Ashviji, what after a long time now? 24 hours, barely 24 hours. Happy New Year in advance to all of you guys out there. Thanks a lot for all your warm wishes. And I really hope, I truly, sincerely hope that at least 2021 turns out to be a good year for all of you guys out there, and all the very best for your board exams as well. May this year bless you with a lot of happiness and good health and everything that you wish for. Yeah. So how many of you guys are excited for your New Year celebrations and all? Sabi, yeah, exactly, Ashri, exactly. Happy New Year, people. Happy New Year. Sure, sure, Kanduri. Why not? Good evening, people. Hi, Rekha. What's up? Excited? Awesome. So, what are your plans, people? What are your plans for your New Year celebrations? How many of you guys are going out, or how many of you guys are stuck at home? Yeah. Good evening, everyone. Good evening, you are. I'm great, Prasoon. Thank you for asking. How are you doing? What's my resolution? My New Year resolution is first to get a haircut. That's my first resolution. That's my first to-do list. Get a haircut on Jan 1st, and then probably take good care of myself. I have to start eating healthy rather than eating outside. That would be my New Year resolution. I hope that you guys have thought of yours as well. Anyways, once again, a very, very happy New Year. My name is Anoop, and this year is Vedantu 9th and 10th English channel. And today, people, is going to be the day where we're going to be solving 10 amazing questions, like super awesome questions of current electricity. The first couple of questions are going to be pretty easy, just to warm you people up. So you know the rules. You have to go to www.menti.com and get ready for the code. I'll be putting up the code on the screen once I've started the quiz. So I'll just tell you the rules. You have 10 seconds to read the question, and depending on the question, you'll get about 1 minute to about 1.5 minutes to solve the question. If the question is short, then you might just take it that 30 seconds to solve the question as well. So you have enough time to solve the questions, probably not that much as you think, but yes, good enough for you to get those questions right. But yes, this is a platform for you to make as many mistakes as you possibly can. I want every one of you guys to take part in the quiz. All of you guys are here right now. You have to join the Mentimeter as well and take part in the quiz. Make as many mistakes as you possibly can, but learn from those mistakes and do not repeat those mistakes in your board exams, right? So that is the whole point of that is this. So with that said, let's get into today's session with a simple quote for today. The quote for today is this: the happiness of your life depends on the quality of your thoughts. And I don't think there's anything that I have to say, but it is true, people. Whatever you believe is right, that is what is going to happen in your life as well. It might not happen today, it might not happen tomorrow, it might happen 10 days from now, it might happen a week from now, maybe 20 days from now. It does not matter, but ultimately what you believe is what is going to happen. So keep your thoughts clean for 2021. Don't go into 2021 thinking about what happened in 2020. Keep a good clean thought and let the world take its path. Right? So with that said, let's get started. I know that all of you guys are like losing your mind, but this was your homework in the last question, guys. Before I get into the quiz, you can go, all of the people waiting right now, quickly go to www.menti.com and be ready. I'll just quickly solve this question and then we'll come back to that. Right? The question was this: what is the current drawn? A geyser is rated as 1500 watt and 250 volts. Find out what is the current drawn from it. It's a very simple question. So P is equal to V into I is the formula. You know what is P? It's 1500 and voltage is 150 is equal into I. So what is I? I is equal to 1500 divided by 250. 0 gets cancelled, which is nothing but 6 amperes. So if you simplify that, you'll get a 6 amperes. So that was the answer to the previous question. I hope that you guys were able to solve it. How many of you guys did solve this question from the last question? All those who attended the last session, how many of you guys actually solved this question? Tell me the truth. I'll tell you the code in a minute. In a minute, we'll be starting the quiz. Don't worry, people. Hi, Preeti, what's up? No, that's it, Ashmi. That's what. You did? Arre, Rahman, Subrot also. Arre, awesome. Keep it up, people. Keep it up. All right, then. That's it. No more talking. Questions time. 10 questions, back to back, all related to the same chapter, current electricity. Quickly go to www.menti.com, menti.com. All those are new. All you have to do is open up a new tab, enter this website, www.menti.com, and enter the code. Do not forget the code. Once you are entered in, they'll ask you for a code. The code for today is 9646776. A lot of sixes. All right. So 9646776 is the code. Enter and join the quiz. Yeah. I know, Ashmi, I know. Hi, Kethi, what's up? Welcome back. This is the code, people. Quickly join the Menti, everyone. I want all 60 people to join the quiz. Quiz is not opening the job. All you have to do is refresh the page. Now, refresh the page once and quickly do it again. The code is 9646776. Enter the code again and join it. Yep. Hi, Pinaki, what's up? Hi, Devpita. Sure, Devpita. Why not? 100%. Today, it's all right, Kethi, no worries, you're right on time now, we're just about to start the quiz. Alright people, so I think everyone's in. I'm going to start the quiz in 5, 4, 3, 2, 1. The first of the 10 questions. Go ahead people, let's go. This is the first question. Read the question carefully, it's a simple one, but go ahead and do it. If work done in moving a charge of 20 microcoulomb from infinity to point O in an electric field is 15 joules, then what is the electric potential at that point? They've given you the charge as 20 millicoulomb, and they've also told you what is the work done as well. That is 15 joules. Find out what is the electric potential. Right? Go ahead, people. Your options are 560 volt, 750 volt, 250 volt, or 500 volts. Let's go, people. Let's go. Why now? What did I do, Ashmi? Katti, it's what did I do? Give handwritten notes. Yes, Shweta, all the handwritten notes would be there in the description. So once the class is done, within 1 or 2 hours, the handwritten notes will be uploaded. So once you click on the description, you can find that out. Don't worry. All right. Okay. The good start, people. Good start. Not a bad start at all. 250 of you guys went with option number C for some reason. About 19 of you guys went with option number C. That was 250 coulomb. But 40 of you guys went with the right answer. That is a good start, people. Congratulations to all those guys who gave the right answer. How do you solve this question? It's pretty damn easy, guys. If you've made a mistake in this, it's probably calculation mistake, not the formula part, because it's quite simple. We know that potential difference is nothing but the work done to move a unit charge from infinity to a point. So this is the formula. But yes, guys, here the current is given as 20 millicoulomb. All right. First of all, convert this to your coulombs. So that is divided by 20 divided by 1000, which is equal to 0.02 coulomb. So it will be 0.02 coulomb. Now put that in the equation. So V is equal to 15 divided by 0.02. That if you divide it, you get as 750 coulomb. So 750 volts, not coulomb, volts. That's all right. So look at those kind of units. This is where you guys make mistakes. How many of you guys made this mistake? Tell me that truthfully in the chat box. How many of you guys made this mistake of not converting from millicoulomb to coulomb? How many of you guys made this mistake? Pinaki, you did? Pratik also. No, B's giving no. All right, that's good. If you've made this mistake, look for these kind of units, guys, because that is where you end up losing marks. No, it's not only pertaining to this chapter. In whole of physics, that is where most students miss marks because of this simple unit conversion and all that. Make sure that you focus on that, and you'll avoid all those kind of mistakes, right? So this is the first question. Ananya on the top, followed by Rajat, followed by Hina, followed by Nijam. High five to you too, buddy. Then it's Beyonce. All right, Pranali, Siddesh, Vroom, Sampreet and Rudraksh as well. 9th grader will win. All right, let's see. Moving on to the second question, people. 9th graders openly challenging all the 10th graders. Let's see. Moving on to the second question out of the 10. Also just join in right now. Quickly join the Mentimeter, people. That was the first question. So you still have a chance to get on the leaderboard. So quickly join the Mentimeter, www.menti.com, and enter the code 9646776. I'll give you 10 seconds. Quickly join it. Once you're in, we'll get started. All right. So there are about 90 of you guys here. So quickly join the Menti. Let's go ahead. All right. Okay. I'm going to start the quiz in 5, 4, 3, 2, 1. Moving on to the second question for the D people. Go ahead and take a look at this one. Come on. Keeping the potential difference constant, the resistance of a circuit is halved. How much does the current changes? Keeping the potential difference constant, the resistance of a circuit is halved. How much does the current change? Options are the current gets halved, the current gets doubled, the current gets tripled, or becomes 1/4. Go ahead, guys. 30 seconds. You have 40 seconds to solve this question. You have another 20 seconds to get it done. Let's go. 70 of you guys have already answered. Interesting. Devpita, today though, no, because right after this I have another 3 more sessions. So yeah, today I'm packed. Sure, Ashmi, sure, why not? Laddu question. All right, Prasood. Let's see how many of your friends are able to give the right answer. That'll help us understand whether it's laddu or whether it's like I don't know the opposite of laddu, something opposite, like Mysore Pak. Alright, 58 of you guys were able to give the right answer. That's more than half the class. That is not a bad number. Yeah, people. Good one again. 17 of you guys went with half, but it's actually going to get doubled. It's actually pretty easy question, guys. Once again, all you have to use is Ohm's law. So potential difference is kept constant. What will happen to this? First of all, V is equal to I into R. We already know that. Now here they've told you that the resistance of the circuit is halved. So what will happen to the resistance? It'll be I into R by 2. So what will happen to the current? So what is current? Current is equal to V by R, which is nothing but V by R by 2. So 2 will go to the numerator. So what will happen? V by R into 2 is what you're going to get. I is equal to V by R into 2. What is V by R? So from this equation, you can say that I is equal to V by R. So you can say that you can substitute that in place of I. So it will be I into 2. So or basically I into 2, or the current will get doubled. So you can say that new current I dash is equal to 2I. That's it. Simple. Alright. So here you can take it as I dash. Just to avoid confusion, you can take it as I dash. That's it. So that is the answer, people. Simple as that. It will get doubled, not halved. Look into those simple, silly mistakes where you end up losing all these 1 mark and 2 mark questions. Please avoid that, guys, because I'm pretty sure that by now you can solve all your 5 mark and 3 mark questions. You're confident with that. These are the places where you lose those 1 mark and 2 mark, and your aim would come down. So please make sure that you avoid those kind of mistakes. Ananya once again being the fastest to answer the question. Congratulations. Followed by Hina, followed by Crazy Boy Physics Lover, followed by Rudransh, followed by Siddesh, then it's Pranali, Sandesh, Avneek, Moksh, and Word Code. Congratulations, people. Well done. Moving on to the third question. So we are one third of the way through. Moving on to the third question. Here it is, people. Take a look at this one and read it carefully and then answer. The question is this. The potential difference across wire is 75 volt and its electrical resistance is given as 30 ohms. Find out the electrical current through the wire. They've given you the voltage or the potential difference. They've also given you the resistance as 30 ohms. Find out the current. Such an easy question. Such an easy question. Please don't get this wrong. Please don't get this wrong. Your options are 2.5 amperes, 0.25 amperes, 3 amperes, or 0.5 amperes. Let's see. Bees Gaming. Hi, Borong. What's up, buddy? Good evening. Yes, ask me. Sorry, ask me. All right. It's all right, Bhargavi. Mistake though happens from all of us. It's okay to make mistakes. Those kind of mistakes are fine. But what you have to avoid is your technical mistakes. Your concepts should be strong. 70 of you guys gave the right answer. That is probably the highest that we've gotten so far. That is not a bad number at all, people. Absolutely wonderful. Yes. It is absolutely correct. How do you solve this question? It's pretty damn easy again. It's same thing. You have to use Ohm's law again. So V is equal to I into R. They've given you the voltage as 75, and I is what you're supposed to find out, divided by 30. So I is equal to 75 divided by 30. 3 to 60.5 is what you're going to get. 2.5 amperes would be the right answer. Amazing, guys. Amazing. Not bad at all. If you made a mistake in this, that is probably calculation mistake. That is okay. That 10 and 5 calculation mistakes are perfectly fine, but do not get your concepts wrong. Concept, though, you have to get some nice beatings for that. Don't get your concepts wrong. Make sure that you get your concepts right. It's okay to make calculation mistakes. That's okay. All right. Anyways, Ananya still on top. Was the fastest to answer. Ananya is taking a good lead, not leaving anyone at all. Followed by Siddesh, followed by Crazy Boy Physics Lover, followed by Rudraksh, followed by Pranali, followed by Sampreet, Avneek, Moksh, Vodkot, and Sanchit, NTSE aspirant. Congratulations, buddy. Well done. Moving on to the fourth question. I hope you guys are ready for the fourth one. Get ready for it, people. Here is your fourth question. Take a look at this one again. Read the question carefully, relax yourself, and then answer. I'm going to start the quiz in 3, 2, 1. Go ahead, guys. Read the question carefully. Come on. The question is this. A wire of resistance 3 ohms and length 10 centimeter is stretched to length 30 centimeter. Assuming that it has a uniform cross section, What will be its new resistance? The wire of resistance 3 ohms and length 10 centimeters stretched to length 30 centimeter. Assuming that it has a uniform cross sectional, what will be its new resistance? Your options are 25 ohms, 30 ohms, 27 ohms, or 15 ohms. You have 30 seconds to solve it. Let's go, people. Come on. Yes, yes, yes. It's all right. Are, Devpita, chill. So it's perfectly fine. Perfectly fine. I have never felt it like that. So chill. No worries. Nijam, please try it again. Refresh the page and try it again. I'll do it. Oh, is it? That's nice, Prameshwar. That's amazing, buddy. All the best, all the best. Congratulations. That's a really noble thing that you're doing. Yes, Abhinav. I am from Kerala, buddy. I'm from Canada. Today, Gokul sir was alive. Oh, is it for certain? So, how's Gokul sir doing after marriage? 43 of you guys were able to give the right answer. Not bad at all, guys. There's a little confusion here and there. That is very clear. 20 of you guys went with option number B, and about 11 of you guys with option number D. That's not a bad number, but still could have been a lot better if you had made a simple avoided a simple mistake of not calculating the area. See, here's the thing, guys. It's very clear that the resistance is 3 ohms. What is the formula for resistance? Anyone who remembers it? Resistance is what? Rho, that is resistivity into length divided by area. This is the formula. So that resistivity into length by area is given as 3 ohms. Now the length is given as 10 centimeter. But what is the new length? I'll take it as L dash. L dash is what? 30 centimeter. Which is what? Which is 3 into L. Because L is 10 centimeters, 3 times the length is what they're saying. So the length has been increased 3 times. So L is what? 10 centimeter. So it's 3 into 10 is what? 30. So I'm going to take it as 3L. That is my origin. That is my length that they've increased right now. Now, if the length is increased 3 times, what would happen to the area? Now, how do you calculate that? Is very simple. We know that volume is equal to area into length. We've already seen that. Now, the new volume would also be the same because the volume is not changing, but the length of it is what? I'll take it as A dash, that is a new area. Length is 3L. So I'm going to equate both the equations. So A into L is equal to A dash into 3L because the volume does not change. I'm only increasing the length, the volume remains the same. So what happens to A dash? So LL gets cancelled. So what are you left with? A dash is equal to A by 3. So what does that mean? The new area, when you increase the length 3 times, becomes less, or basically it becomes 1 by 3rd of it. The area will become 1 by 3rd. If the length is increased 3 times, the area will become 1 by 3rd of it. So now put this in this equation. So R is equal to rho L by A. I'm going to substitute all this. So I'll take it as R dash, that is a new resistance. So R dash is equal to rho into L is 3L divided by area is A by 3. So simplify the equation. R dash is equal to rho into, I'll take this 3 to the numerator. So what am I going to get? It will be L by A into 3 is 9. So I'll get as 9. Now what is rho L by A? Anyone in the chat box? What is rho L by A? What is the value of rho L by A? Anyone who is listening properly, what is the value of rho L by A? R, exactly. What is the value of R? R is nothing but 3 ohms, exactly, because we know that this is what it is. Rho L by A is what? 3 ohms. So I can just substitute that in place of rho L by A. I'll take it as 3. 3 into 9 is what? 27 ohms. That's all. Okay, tell me the truth. How many of you guys made a mistake in this step? How many of you guys took the area as it is? Tell me the truth. How many of you guys made this mistake? Hi Dishuk, chill. Yes, Manav Sugamada, how are you doing? Yes, people, how many of you guys made the same mistake? How many of you guys did not take the area? Nobody. Oh, nobody's able to. Okay, Avadh, all right. Not me. All right. Let's see. Right now you can lie down, but in your final exam you can't. So remember this, people. If the length is increasing, then area should also differ because the volume is kept constant. So it's obviously going to differ. So here if the length is increased, then the area will become 1 by 3rd of the actual area. All right. So anyways, guys. Physics Lava is on the top, followed by Rudraj, followed by Mox, then it's Isaac Newton. Oh my god, such great personalities and all. Bless us, oh Lord. Followed by Vote Goat, followed by Sampreet, Siddesh, Kwahish. Congratulations, buddy. Fastest to answer. Followed by Sanchit and then Prasoon as well. Happy New Year to you too, buddy. Congratulations. Well done. Moving on to the 5th question, where halfway through, 50% of the way is done. The fifth question, all those who got out of the quiz, quickly join it once again, people. We still have 5 more questions to go. So quickly join the Menti meter once again. The code is 9646776. That is the code. Quickly join it. I'm going to be starting the quiz in 10 more seconds. Quickly do it, people. Hi. Welcome, welcome. Hi, Kadesh. Hi, Kadeshka. What's up? Welcome, welcome, welcome. All right. I'm going to start the quiz, people, in 3, 2, 1. Moving on to the fifth question for the 50% of the way done. Take a look at this one. Come on. An electric bulb is rated 100 watt 250 volts. How much current will the bulb draw if it is connected to a 250 volt supply? Go ahead, please. Come on. When did I start wearing spectacles? I think since I started using laptops a lot. Like, no, Ashmi, no, nothing like that. No. Any proper answer from Brad? Sure, David. I'll see if I can help you with that. Alright, guys, come on. Let me know what is the answer. You have 30 more seconds left. Come on. Hi, Aarti. What's up? After doing some example, is it important to? Yes, definitely, Tony Stark. Past year papers are very, very important. Don't ever ignore that. That is going to help you a long way. That is going to help you a long way. For the past 10 years, solve the past 10 years question paper. That's very, very important. That is till 2010, solve all the question paper. It's very important. Don't ever do that. Yeah, exactly. This is going to be the last session of 2020 of physics. No, that's it, people. Then 2021 is going to start, which is like another couple of hours. How many more hours are left? Okay, let's see, more than 12 hours, I believe. Anyways, more than 6 hours, no? 12 hours. It's hard. 51 of you guys were able to give the right answer. Not bad at all. Not bad. 10 of you guys with option number C, then A and B was chosen by 7 people each. Don't worry, people, but that is still a very good number, and it's a damn easy question, guys. It's actually a very, very easy question. How do you solve this? Very simple. Now we know that P is equal to V into I. Power is equal to voltage into current. Now the voltage is given as, the power is given as 100 watts. The voltage is given as 250 volts. Into I, so all you have to do is find out the current. So current is equal to what? 100 divided by 250, 0 gets cancelled. 2, 5, 2, 10, 5, 5, 25. So it's 2 by 5, which is nothing but 0.4 amperes. That is it, people. That is all. Such an easy question. How many of you guys made a calculation mistake in this, people? Why are you doing calculation mistakes in such easy questions? Please avoid such mistakes. That is what is going to end up losing so much mark, because you know that the first couple of the first sections and all, you have these 1 mark question, 2 mark question. Please avoid such mistakes. All right. But anyways, guys, before we move on to the 6th question, I have a very important announcement to make to help you guys out to do better in your exams. If you want to be a part of us and study with the best of the best teacher, with the best of the best online platform there is, all you got to do is click on the link that is given in the description, as well as on the pinned comment section as well. The link will take you to the Vedantu website, wherein you have the option to study with, again, the best of the best teacher, wherein you have the opportunity to learn unlimited live classes with the highest level of quizzes, just like this one, in every session that you take. You would be experiencing the whole world, where you can compete with the rest of the world, not just with your school, not just with the state that you're in, not just like it's not just Karnataka or MP or UP, the entire country, in fact the entire world, because you don't have students just from India, you'll be having students from all over the world. So you have the opportunity to compete with the rest of the world and see where you're at. If in case you miss out a session, don't worry, people, because you can watch the recording of every session, and more importantly, you have the interactive replay session, wherein you can take the live quizzes and see the leaderboard even if you miss out a class, because live classes are going on 24/7, and it's impossible for a person to attend all 24 sessions in one day. That's not possible at all. But still, guys, do not worry, you can still take the quiz, you can still check out the leaderboard of every single session and get the handwritten note of every single class. You have all the premium content and the handwritten note of every single session, every single teacher, so you never miss out on anything that is important. With all of these, you have the opportunity to get your doubts cleared inside the session itself, because you don't just have one teacher, you will not just have the master teacher to help you understand the concept, but together with the master teacher, you'll also have someone called as a class teacher to help you clear every single doubt of yours. With this, you have the tests and assignments, because if you're someone who are looking for tests and assignments to practice, like many of you get asking for previous year question papers and all, you want someone to if you want someone to check those tests and give those kind of tests very periodically, then yes people, this is the platform for that. If you're someone who is not prepared at all, who's just starting with the preparation, if you're someone who is completely prepared and looking for revision, if you're someone who has completed the revision and you want to revise it again, does not matter which category you fall under, because our revision sessions, our sessions that are there, is going to help you guys do much better in your board exams as well. With all of these, you have 5,000 plus micro courses of all the chapters of all the sessions. With that, some free crash courses as well. So all of that for free. All you gotta do is click on the link that is given in the description. With all of these advantages, you get a lot more as well. All you gotta do is enter the coupon code AME Pro to avail the discounts as well, because if you go for the 1 month program, the base price of that is around 2,699. If you use the coupon code AME Pro, that's my coupon code basically. If you use the coupon code AME Pro, you get a discount of about 500 rupees. And what happens to the price is that it comes down to 2,159 rupees. If you go for the 3-month program, which I would suggest you guys to do, because you have 3 more months for your exams. So if you go for the 3-month program, that's about 7,000 rupees, 6,999. If you use the coupon code AME Pro, you get a discount of 1,400 rupees, and what you're essentially paying is 5,599 for those 3 months. Now, it looks like a lot of money, but think about it, people. In that 1 month, in that mere 1 month, you would have roughly attended about 250 sessions, a minimum of 250 sessions. So that means that per session, you're roughly paying about 9 rupees. If you go for the 3-month program, you're paying even less, because you've attended about 750 sessions in that 3 months duration. And what happens to the price is that it drops down to 7 rupees 5 paise, so 50 paise. So basically what you're doing is paying less than what you pay for a packet of Lays or any other sweets or any condiments for that matter, to for your own education, for your own preparation for your board exams, right? Again, the link is given in the description as well as in the pinned comment section, and the coupon code is AME Pro to avail your discounts. With that said, let's get back to the quiz now. I know that you guys are waiting for the leaderboards and the quiz, so quickly people, all those who got out of the quiz, join the quiz back immediately. I'll give you 1 minute to join it. Quickly join back. The code is 9646776. This is the leaderboard at the end of that 5th question, halfway through, and has challenged Mr. Rudraksh goes to the top, followed by Crazy Boy Physics Lover, followed by Moksh, followed by Isaac Newton, then it's Sampreet Kwahish. Congratulations, buddy, once again. Sudesh, Sanchit, Sriram, and Rishank. Good to know, buddy. Welcome to the session. Absolutely wonderful, guys. Absolutely wonderful. Rudraksh, like where is all the 10th standard students? Huh? Where are all the 10th standard students at? What are you guys doing? You're letting a 9th grader win. Puppy shame. Alright, quickly join the quiz, people. Once again, the coupon code is the code is 9646776. Quickly join the Menti meetup so you can move ahead with the quiz. The website is www.menti.com, menti.com, and the code is 9646776. Because I see a lot of you guys over here who are not in the quiz, so quickly join it. I'm going to start the quiz in 5 more seconds. 4, 3, 2, 1. Go ahead, guys. Moving on to the 6th question on your screens right now. Take a look at this one. In a circuit shown below, calculate the net resistance of the circuit. If you can see it, it's 10 ohms, 15 ohms, 20 ohms, and 5 ohms. All right, 10, 15, 20, and 5 ohms. Your options are 15 ohms, 18.5 ohms, 24 ohms, or 12.5 ohms. You're supposed to find what is the net resistance. So it's not minus 10, it's 10. All right, it's not minus 10, it's 10. Wait a second. It's 10. 10 ohms, 15 ohms, 20 ohms, and 5 ohms. And the voltage is 45 volts, I think. I'm not able to read the question. It's so tiny. The image is so tiny. I can't see it. But still, I hope you guys are able to pick up the question. So why conductors, why not become hotter when kept alone? Not in circuit, because electrons only. Gaurav, because they are moving, the electrons are moving, but not at that high rate. Not at that high rate. So the collisions are minimum. The heat energy produced is also very minimum. All right, it's it's because obviously the surface area of a wire is big enough to dissipate that heat, so you'll not feel the heat at all. But when you're connected to a battery, you're creating a potential difference. So the electron movement or the charge movement is much more faster. So more will be the collision. So the heat gets dissipated, and that's why you feel it really hot, right? Anyways. 12.5 is apparently the right answer. 53 of you guys were able to give the right answer. Not a bad number, not a bad number. Proud of you people, absolutely wonderful. 10 of you guys going with option number B, and 3 and 4 for option number C, A and D as well, A and C as well. Congratulations. Howard, how do you solve this question? It's actually pretty easy, guys. So all you have to do is find out the net resistance. So first of all, I'll name this as R1, R2, R3 and R4. Alright, first of all, if you look at it, R1 and R2 are in series. Now, in the chat box, people, what is the equivalent resistance if two resistors are in series with each other? Quickly. What is it? Yeah, what is it? 25 ohm. What is the equivalent resistance? What is the formula to calculate equivalent resistance if the two resistors are in series with each other? Nobody knows it or what? No, but n by 2, is it? Exactly. R1 plus R2. Now, I'm not asking for the answer. I'm asking for the formula. It's R1 plus R2. So R1 plus R2 is what? It's 10 plus 15, which is nothing but 25 ohms. Absolutely, 25 ohms is the right answer. But I'm looking for the formula. All right. Now again, if you look at this one, this is also in series. So I'll take it as R dash just for my understanding. So that's R3 plus R4, which is nothing but 20 plus 5, which is again 25 ohms itself. Now that you've solve the circuit, this is what my circuit looks like right now. After I solve it, this is what my circuit would look like. So I have connected a battery to it, which is again 45 volts. And yes, this is what my circuit looks like. So this is 25 ohms and this is again 25 ohms. Now these both are in parallel. So what will be the formula for parallel resistance? The equivalent resistance of parallel is basically what? It's 1 by R1 plus 1 by R2. So what is 1 by R1? That is basically 25 plus 1 by 25, which is nothing but 2 by 25. This is 1 by R equivalent. So what is R equivalent? That will be the reciprocal of that, which is nothing but 25 by 2. So 21224.5. So the total resistance is nothing but 12.5 ohms. That's all. Simple, easy. Now, guys, listen carefully. If you are, if you are asked, it has a 3-mark question or something like that, try to draw this circuit also, try to draw the equivalent circuit as well, so that you show the teacher that you have understood the concept. So that will be, it'll be an added advantage. But if you don't have time, then don't go for it. But if you have time, if you know that you can do it, you can still make it through, then you can draw the circuit, helping you to understand. The teacher will understand that you've actually understood the concept. So it'll be an added advantage. But again, I don't force you people to do it. If you have time, if you have the liberty of time, then go ahead and do it. If you don't have time, then don't do it. All right. So anyways, here's your leaderboard once again. Rudraksh still on top, I believe, followed by Crazy Boy, followed by Moksh. No, Moksh moves on to the top. Sleeky Boy, followed by Rudraksh, followed by Sampreet, then it's Isaac Newton, followed by Sandesh, followed by Crazy Boy Physics Lover, Kwahish, Vote Goat, congratulations buddy, Akshat and Prasoon as well. Congratulations. Well done. Moving on to the 7th question for the day. Go ahead, people. The 7th question. Let's go. Here's the 7th question. The question is, calculate the effective resistance between the points A and B in the circuit shown in the figure. Such an amazing question. Go ahead and do it. Let's see how many of you are able to give the question, give the right answer for this. You had 1 minute 30 seconds to do it. Your options are 5 ohms, 10 ohms, 3 ohms and 2 ohms. And if you look at the resistors, it's 1 ohm, 1 ohm, 1 ohm, then 2 ohms, 2 ohms, 2 ohms, 2 ohms, and then 1 ohm. Let's go. So why the directional flow of current is opposite in the direction of electrons? Because Pinaki, because until the discovery of electrons happened later. So it happened later in the 17th century. So before that, what we believed was that current is flowing from positive to negative. So what happened was that the whole physics community, the whole scientific community had done a lot of experiments based on the same principle that current is flowing from positive to negative, because we always took it as positive to negative. Because for example, if you talk about heat, flows from hot objects to cold object, wind, high pressure to low pressure. So we consider positivity to be higher and negative to be lower. So until then we had done a lot of experiments, so we didn't want to change it back. So we took that as the conventional current. Conventional current is positive to negative, but the actual flow of charge is from negative to positive. This is one. All right. That is the reason why we took it like that. All right, Pinaki, I hope you understood the question. C programming or Python, both are good. Python is more widely used these days because that is what I've heard. But yeah, I'm no one to answer that question though. Why so laddu question now? Only these kind of questions is what you can expect now. They're not gonna ask you some board, like they're not gonna ask you some IIT level questions and all. So don't worry, chill out. 52. My God, guys, my God, that is an absolutely wonderjastic, blunderjastic number. Well done. 9 of you guys going with option number A. That is the highest majority. That's really good, guys. That's really, really good. So how do you solve this question? It's very, very easy. Okay, what was the question? How this was the question, right? First of all, what I would do is simplify the circuits by adding up whichever are in series. So if you look at it carefully, I'll take this as R1, I'll take this as R2, I'll take this as R3, this is R4, this I'll take it as okay, I'll take it as R5, this will be R6. Okay, we'll take this as R6, all right, this is R7, and this is R8, and this is R9. Oh, all right, anyways, so there are 9 resistors which are connected. Some of them are in series, some of them are in parallel. Now, look at this. R2, R3, and R4 are in series. They are basically in series because the current flowing through them is the same, so it's going to be in series. So I'll take that first. So I'll take it as R series, RS is equal to R2 plus R3 plus R4, which is nothing but 1 plus 1 plus 1, which is nothing but 3 ohms. So first thing is that I've simplified this circuit. So all of this will get cut out and I'll have just one resistor like this, which is of 3 ohms, right? I've done that. Now, these are also in series. These 3 are also in series. That is R6, R7 and R8 are also in series. So I'll take that as let's take as RS dash, all right, just for my understanding. So R6 plus R7 plus R8 are also in series, which is 2 ohms plus 2 ohms plus 2 ohms. So that's 2 plus 2 plus 2. So that's 6 ohms that you have. Now, you have taken out the circuit. You've simplified the circuit to be something like this now. So this is 6 ohm now. So now look at it carefully. This one and this one and this one, they're all in parallel with each other. So I'm going to find out the equivalent resistance. They're all parallel, so I'll take it as 1 by Rp, the parallel resistors. So that'll be 1 by R dash S plus 1 by R5, right? That's what I'm going to get. So what is 1 by RS? 1 by RS is 1 by 3 plus 1 by 6 plus R5 is 1 by 2. So this is what I'm going to get. Now find out the LCM. I know it's a little long, but find out the LCM. So 6, you can take 6 as the LCM. So 3 into 2 is 6 and 2 into 3 is again 6. So we'll get it as into 2 and into 3. So you'll get it as what? 2 plus 1 plus 3 whole divided by 6, which is nothing but what? 3 plus 2 is 5, 5 plus 1 is 6 again. So 6 by 6, which is nothing but 1 ohm. So what you've done is basically you have simplified the circuit to look like this right now. So this is A and this is B now. You have simplified all of these things and you have made it as 1 ohm. And this is already 1 ohm and this is also 1 ohm. So add them both, add all the 3 up. So this is R1, this is RP and this is R9. So that's 1, the R total, take it as RT, the total resistance is 1 plus 1 plus 1, which is nothing but 3 ohms. That's it, people. That's it. I know. It's simple. No? It's such a simple circuit. But yes, guys, this is a little longer, but it is an easy, very easy circuit. So yes, people, that would be the answer for that question. Congratulations once again for all of those who gave the right answer. Absolutely bang on, people. Rudrank still on top, followed by Sampreet, followed by Siddesh. Crazy boy, no, Siddesh on the second, Kwash on the third, Sampreet on the fourth, Crazy boy on the fifth, Prasoon on the sixth, Akshit, Aditi, Vote Goat, and Rishank as well. Congratulations. Well done. Beautiful looking leaderboard. Moving on to the 7th question. If I am not wrong, this is the 8th question. Sorry, 8th question. Almost done, people, just because now these 3 questions are going to be a little harder. All right, we're going to take it to another level right now. So pay attention, give your 100%. There's going to be a little bit of complications here and there, but read the questions carefully and then answer. The last 3 questions are just amazing questions, like super awesome, mind-blowing questions. The first question: a cell supplies a current of 1.2 amperes, all right, through a 2 ohm resistor connected in parallel. And when resistors are connected in series, it supplies a current of 0.4 amperes. Calculate the internal resistance and the EMF of the cell. Yeah, you heard that right, people. EMF and the internal resistance. Your options are 0.5 ohms and 1.5 volt, 0.5 ohms and 1.8 ohms, 2.5 ohms and 8.3 volt, or 3 ohms and 3 volt. Let's go, people. Here, this is the question. A cell supplies a current of 1.2 amperes through a resistors of two resistors are connected, one in parallel and one again in series. When they connected in parallel, the current flowing through them is 1.2 amperes. When they connected in series, the current flowing through them is 0.4 amperes. Calculate the internal resistance and EMF of the cell. A, alright, a lot of you guys are going with A. Happy New Year to you, to above. B, alright, you think, alright. A lot of you guys are going with A. I don't know why you're going with A, but let's see. I don't know if that is the right answer. I'm gonna have to calculate it. Let's go. Go 2 to 21. Yeah, exactly. Alright, Ashmi, no worries. Alright, guys, go ahead. Go. Let's see how many of you are able to give the right answer. Let's go. Another 10 more seconds. What is EMF? Good question. Good question. Very good question. EMF stands for electromotive force. We have done that in detail in the third session, I believe. Please watch the recording, buddy. It'll superbly help you out. Make sure that you watch it. 26 of you guys were able to give the right answer for this one. 33 of you guys went with option number A for some reason. How many of you guys went with Jai Mataji? Tell me the truth. Like, you didn't even think about calculating it. You were like, sir, let it be. How many of you guys did that? Tell me the truth, people. Tell, honest to God, cross your hearts and tell me how many of you guys did that. How many of you guys went with Tukkamar? Like, you're like, sir, it's okay. Jai Mataji. A should be the right answer. Me or? Always, no? That's it. I'll explain guys. I'll explain the question, guys. Listen very, very carefully. It's a very interesting question. One of the most important questions as well. So listen carefully. First of all, guys, you're supposed to find out what is the internal resistance and EMF of the cell. Now, if you've watched the previous recording of this, I've clearly told you that when you talk about EMF is nothing but when you buy a battery. I'll just explain what is EMF first. If you buy a battery, it'll tell you that let's say that you buy a 1.5 volt battery. All right, you buy a 1.5 volt battery. Now, when you buy it from the shop, they'll promise you that it'll provide a potential difference of 1.5 volt. That is the EMF. That is what is promised. But when you connect it to a circuit, you might get like 0.8 volt or 0.9 volt. There's a lot of loss happening. That is called as the terminal voltage. What you get is called as the terminal voltage. Now, out of that 1.5, what you're getting is 0.9. So there is a voltage drop. That is what is called as internal resistance. That is because of the internal resistance. So in other words, what I'm trying to say is this. Remember this one formula. Keep that in your mind. EMF is equal to terminal voltage plus the voltage drop, which is represented by capital V and small v. Now, what are these? EMF is V into I. Because why? It's basically, okay, sorry, not V into I, it's nothing but, it's nothing but voltage. So what is voltage? Voltage is current into resistance. So you can write it as what? E is equal to I into R. What is V? V is also I into R. But this R is the total resistance, all right? And then small v is equal to I into small r. This is what is internal resistance. This is what you're asked to find out. Now, here they've mentioned that there are two resistors. One of them or both of them are of 2 ohms. Firstly, they are connected in parallel. First of all, they are connected in the first condition. They are connected in parallel to each other. So both of them are 2 ohms. This is 2 ohms. This is also 2 ohms connected to basically a battery. I don't know what is the EMF of this, so I'm just going to leave it like this. Now, the current flowing through it is said to be 1.2 amperes when it's in what? When it's in parallel. When it's in parallel, the current flowing through is 1.5 or 1.2 ohms. So what is that? 1 by R equivalent. What is the equivalent resistance? Is equal to 1 by R1 plus 1 by R2. Which is nothing but 1 by 2 plus 1 by 2, which is nothing but 2 by 2, which is nothing but 1 ohms. So the equivalent resistance is 1 ohms. All right. So I'm going to put that over here. So for when it's parallel. All right. So listen carefully, guys. It might take a little long. It's a really long problem. So listen carefully. All right. So when it's in parallel, EMF is equal to what is V? V is equal to I into R plus I into small r. That is the internal resistance. So I can write this I into R plus R. I can take the I common. Now either you can see This is also one more formula. If you can remember this formula, that's even awesome. If you can remember this formula, that's more than enough. You can just directly substitute and get the answer. But if you can't remember the formula, then understand the steps and substitute and do it accordingly. All right. So now current is 1.2 amperes. The total resistance is what is 1 ohm. That is the equivalent resistance. 1 plus R. So simplify the equation. So we'll get it as 1.2 plus 1.2 R. Alright, so EMF we found it as 1.2 plus 1.2 R. Did everyone understand this so far? Are you able to understand this, people? In the chat box, are you able to understand how I did it? So all I have to do is remember this one formula. From this, I'm gonna get everything. Now leave EMF as it is because you're supposed to find the EMF as well. Right? Everyone understood this, people? Are you able to keep up with me? Are you able to keep up with me, guys? Please listen. Are you able to keep up with me now? All good? No? Pakka? Clear? No? No, still confusing. So once again, EMF is equal to capital V is terminal voltage, small v is voltage drop. Now please watch the recording, you'll understand it much better. So please watch the recording once and then go back to the same question. Trust me, you'll be able to solve it. Alright. So what I'm getting, this is the first equation that I'm going to get. Now I'm going to erase this part out, guys. I'm going to erase this part out. Sorry, what was that? One second, guys. Let me just erase this one out. Right now, I am going to keep them in. First of all, it was kept in series. Now I'm going to take it as first it was parallel. Now I'm going to take it as series. I don't know what's happening now. What and all am I clicking? Alright, now these two resistors are connected in series. Once again, alright. Now the current flowing through them is what? It becomes 0.4 amperes. Alright, 2 ohms, 2 ohms. What is the equivalent resistance? R equivalent this time will be what? It will be R1 plus R2, which is nothing but 2 plus 2, which is nothing but 4 ohms. Right? Simple. So again, I am going to use the same equation, but this time when it's in series. Right? So if it's in series, again the same thing. EMF is equal to terminal voltage plus voltage drop. So terminal voltage is going to be what? It's going to be I into R plus R again, because like I told you, terminal voltage is I into R and V is equal to I into R, the small r. So what is the current? Current is 0.4. Resistance is 4 plus R. So what are you going to get? 4 into 4 is 16. So it'll be 1.6 plus 0.4 R. Alright? Okay? Now, listen up carefully. I found out what would be the EMF when it's connected in parallel, and I found out what is the equation when I would connect it in series. This is what I got. Now, both of these are calculating the EMF itself. Both of these are calculating the EMF, and EMF is, because it's the same circuit, I am not changing the cell as well, so the EMF also remains the same, which means that I can write it as E is equal to E, because it's the same EMF. Ultimately, no matter how I connect the circuit, as long as the battery or the cell is the same, the EMF of that cell will also be the same. So what I'm going to do is, I am going to equate, let's say this is the first equation, this is the second equation. I'm going to equate both the equations right now. Alright, both the sides. So left hand side, I'll take it as 1.2 plus 1.2 R. Right hand side, I'll take it as 1.6 plus 0.4 R. Right? Are you able to understand, people? Please listen now. Are you able to understand? Please listen. Now, solve for R. So take all the R terms to one side, all the constants to the other side. So you'll get it as 1.2 R plus, minus, no, it'll be minus, one second guys, that's not plus, it'll be minus 0.4, it'll be minus 0.4 R is equal to 1.6 minus 1.2. So this is what, this will be how much? That will be 6, 7, 8, I believe, 0.8 R, 0.8 R, and this is 1.2, right? 1.2, that will be 0.4, right? So R is equal to 0.4 divided by 0.8, which I can take it as into 10. So that will be 4 by 8, 4 2s are 8, that is nothing but 0.5. So you found the internal resistance as 0.5 ohms. Did you guys understand how I got this, people? Did you understand this? Is it clear? Are you able to understand it? Yes or no? All I did was I started all the way from the EMF, found out what would be the EMF if I were to put it in parallel, and how I did it in series. So I equated both the equations. I got the internal resistance as 0.5 ohms. Now substitute this value either in equation 1 or equation 2 and get the EMF of the cell. That's all. So once you find this out, I don't have any place to write, so I'm going to erase the first part out, guys. I'm going to erase the first part, or else I'll erase this one. All right, I'll erase over here. I'll erase this one and calculate the rest of it right here. So look at the top corner, people, the top corner. So I'm going to put that over here. I'm going to put it right there. So first equation was what? It'll be EMF is equal to 1.2 into 1 plus R. You can substitute either of the equation, you'll get the same answer. So 1.2 into 1 plus R is 0.5. So that's what 1.2 into 1.5, which if you multiply, you'll get the EMF, which I think will be around 8. If I'm not wrong, it'll be around 8. I'm not really sure. 1.8, sorry, 1.8. 1.8 volt is what you're gonna get. That's all. Got it? Did you understand this? I know it's a very, very long problem, guys. It's a very, very long problem, but it's a clear 5-mark question. It's a clear 5-mark question. Explain the whole thing again, buddy. I don't really have that much time, but I'll tell you all the main points once again. So remember that EMF of the cell, remember this one formula, EMF of the cell is nothing but terminal voltage plus internal voltage drop. Small v is voltage drop, capital V is terminal voltage, and E, which is also called as epsilon, is nothing but the EMF. So that is what it is. So what is V? If you from Ohm's law, we know that V is equal to I into R. So all I'm doing is I'm substituting that in place of V and in place of small v. In small v, it will be I into small r, which small r stands for internal resistance of the cell. So inside the cell also, it will have some resistance. That is what is small r. Capital R is what is the resistance that you're connecting. So if you have connected two resistors to the cell in a circuit, so that will be R. That will be capital R. What is the equivalent resistance? That will be R. The total resistance will be R. So I just substituted that over here. So I'll get this equation. The EMF is equal to I into R plus R. This is what I'm going to get. So basically I'm substituting the value over here, taking I as common because it's the same current. R into R is what I'm going to get. Now, when the connection is parallel, the equivalent resistance or the total resistance will be different. So I calculated that first. So there are two resistors kept in parallel to each other, both of 2 ohms. You'll get the equivalent resistance is 1. So you simplify the equation, you'll get as EMF is equal to 1.2 plus 1.2 R. That is the first equation. Now again, it's the same circuit, but this time these resistors are connected in series with each other, one after the other. So what will be the equivalent resistance? It will be 2 plus 2, which will be 4 ohms. That will be the total resistance. So in place of R, I'm going to substitute 4 over here. That's all. And the current is also different. If you look at the current, when they are connected in series, the current is 0.4 amperes. So the current will be 0.4 amp. This is what is my second equation. When I simplify the equation, this is what I'm going to get, 1.6 plus 0.4 R. Now, both of these are calculating the EMF itself. Both of these are calculating the EMF. So I can basically equate these both because they are both the same thing. They're both calculating the same EMF, and the EMF of the cell does not change whether you connect it in series or parallel. So I'm going to equate both of them. So this is what I'm going to get. E is equal to E, which is nothing but this equation number 1. So I'll just use a different color. So green color shows equation number 1. This is equation number 1, and this is equation number 2. Alright, so I'm going to equate both the equations, equation 1 and 2. This is equation 1, this is equation 2. Simplify the equation to get R now. So if you simplify the equation, you'll get it as 0.5 ohms. This is your internal resistance, the resistance inside the cell. Once you find out the internal resistance, put it in either of these equations, either 1 or 2, and find out what is the EMF, which you'll get it as 1.5 volt. That's all. That's it, guys. That's it. Alright, moving on to the 9th question. I know that was a long question. That was like really, really, really long. Alright, here is your leaderboard, people, at the end of that question. That was really long. Rudraksh unfortunately chose the wrong answer. It's alright, buddy. Yeah, it's perfectly fine. Physics lover on the top, Prasoon on the second, Sandesh, Rishang, Nijam, Sanchit, Shanvi, Sena, Rudraksh, and Keshav, who was the fastest to answer. High five to you, buddy. Congratulations. Well done. Moving on to the 9th question. A lot of you guys already left listening to the answer for the last one. A lot of them left after the last question. I understand that. It's okay. It's okay. It's okay, people. Moving on to the 9th question. Take a look at this one, people. Another easy question, but it's also a little complicated. Listen carefully. Look at this one. 2 lamps, one rated as 220 volt and 50 watt, and another rated as 220 volt and 100 watt, are connected in series with the main voltage of 220 volts. Which lamp consumes more power? Your options are 50 watt bulbs, A 50 watt bulb, 100 watt bulb, both consume the same power or can't say. Now there are two bulbs which are connected in series. One is a 50 watt bulb, the other is a 100 watt bulb. Both of them has the potential difference of 220 volt itself. The voltage is the same, and you connect it into the main switch, that is about 220, that is also providing a potential difference of 220 volt. Which of them will consume more power if they are connected in series with each other? Go ahead guys, come on. You don't use, no, David, I don't use WhatsApp now. So when you're going to complete, I have exams now. Kirti, two more questions, that's all. This is the 9th question. We have one more question and then we're done. Jai Mataji, no, exactly. That's all. Ashmi is like, all right. Okay, I hope you understood it, Raghav. I hope you understood the previous question. Yeah. Alright. What's the unit of current? Yeah, I completely forgot to check it out. Devpita, just remind me once today, I'll check it out. Alright, just remind me once today. Alright, I completely forgot about it. Take Menti on resistance. Sure, this contains everything. The resistance, the whole current wala chapter is there. Resistance, EMF, everything is there in this one. Alright, but yeah, for 10 standard CBSE, it will be a little different. Alright. Okay. I understand the confusion. 19 of you guys were able to give the right answer. A majority of you guys went with option number B, which is apparently the wrong answer for this question. Now again, this is a tricky question, so listen carefully, people. Alright, listen carefully. Now, first of all, they both connected in series. Alright, they both connected in series. The first one is of 50 watts and this is of 100 watt. Alright, now what is power? Power is equal to V into I, voltage into current. Now I do not know the current, so I'm going to use Ohm's law. I is equal to V by R, and I'm going to substitute over here. So P is equal to what? V into V by R, which is nothing but V square by R, which is one of the formulas of power. You already know that V square by R is one of the formulas of power. Now what I want you guys to do is remember that power and resistance is indirectly proportional, which means that if resistance increases, power will decrease. Simple. And if power increases, resistance will decrease. Do you guys agree with me so far? Are you guys able to understand? Are you guys aware of it? Yes, people in the chat box, give me a quick yes. Yes, are you guys aware of this one? All good so far? Pinky monkey, no. Yes, no, all good. So P is equal to P is indirectly proportional to R. If resistance increases, power will decrease. Now, find out the resistance for the first one. All right. For the first one, power is 50 watt and the voltage is 220 volts divided by R. So what is R? R is equal to 220 into 220 divided by 50. 0 gets cancelled. 22 into 22 is 484 divided by 5. So 5 9 45, 34 5 6 are 30, 5 6 30, 4 5 8 40, right? So you'll get this 968 ohms. This is the resistance for the first one. The first bulb, the resistance is 968 ohms. Got it? The exact same way I'm going to calculate the resistance for the second one as well. Alright, listen up, people. Listen up. Very important. Second one. The power is 100 watt for this one. Again, the voltage is 220 divided by R. So what is R? R is equal to 220 into 220 divided by 100. 0 gets cancelled. 22 is 484 ohms. Now, just by looking at the value, you can clearly see that R1 is greater than R2. R1 is greater than R2. Yes or no, people? Yes or no? Just by looking at the value. Obviously, 968 is greater than 484. Absolutely yes. Yes, people? Clear? Because R1 is greater than R2, the power of it, the power consumption of it is also going to be exactly the same. So if you look at it, so because the resistance is increasing, wait a second, did I do something wrong? Because see, okay, the resistance, when this decreases, this will increase, right? Alright. Exactly now. So because the resistance of the first one and the second one is, the first one is greater than second one, Wait a second. I think I made a mistake, guys. 1 second. No, it's correct. R1 is greater than R2. 968, 484. Okay. Guys, let's go with another one. Alright. Now, heat energy wala formula. H is equal to what? I square RT. H is equal to I square RT. We know that also. So if resistance is increasing, the heat energy will also increase. So energy consumption will also be more. If the energy consumption is more, obviously the power is also going to be more. So that means that, so I'm not going to use this one because the relationship is not exactly correct. I can't write it like this. This will not make any sense. So I'm going to remove this. I'm going to use the heat wala formula. H is equal to I square RT. What is H? H is nothing but the heat energy. I is nothing but the current. R is nothing but the resistance. And T is nothing but the time taken. Now here obviously the first one, resistance for the first one is more and the resistance for the second one is less. So heat energy of the first one would be much more greater than heat energy of the second one. Because of this, you can say that power consumption of the first one is much more greater than the power consumption of the second one. Got it, people? So in other words, this will consume more power. 50 watt will consume more power in comparison to the 100 watt bulb. Got it, guys? Did you understand this? Is it clear now? Exactly, yeah, I can use that now. Oh yeah, you can say that, you can use that one also. That is, instead of using voltage, you can use it as P is equal to I square R wala formula also you can use. Yeah, that will also make sense. Yeah, instead of using this one, use this one. Yeah, that will make sense because this is not correct. If I had used this one, no, this is definitely going to be wrong. So yeah, use this relationship. Either use I square R wala relationship or you can use H is equal to I square RT. Alright, that's all. That is it, people. So you can use this and you'll be able to find out the answer. So what did they do over here? They used, I square R wala, not V square by R. They use I square R wala formula. Yes. So that'll be the answer, guys. Alright. That is it, people. That is it. One last question now. The last question. Take a look at this one. I know that it's getting a little harder, but the last question is pretty damn easy. So listen carefully and you'll be done. Alright. Yeah. So can we use V square by RT? V square R by RT. You could, but the relationship would not be correct. If you use that, no, because that means that if the resistance is decreasing, then the heat energy should increase. So you can't use that relationship. That is the same mistake that I did. Do not use V square by R wala relationship. Use current wala relationship. You know why? One more reason why you have to use the current wala relationship is because they are connected in series. And in series, the current will be same, but voltage will differ. Now see here. If the reason why I should not use this is because I made this blunder. Because voltage is different. No, when you talk about series connection, voltage will be different. Current will be the same. So because of that reason, I have to use this relationship, not the first one, because it's connected in series. If they were connected in parallel, then I could have used this one because the voltage will remain same. But here the voltage is differing, so I can't use that relationship. I have to use this one because current will remain same. Got it? That is why I have to go with this one. That is where I made mistake. Don't repeat the same mistake. Anyways, Prasoon, Crazy Boy, then it's Nijam, Sanchit, both of them were the fastest. Congratulations, buddy. Then we have Rishank, Rudrank, Saini, Keshav, Bodhi, McBoat Face, and Sandesh as well. With that said, guys, last question, and we are done. The last question, the ultimate question. It's going to be a very easy one. What was that? Alright, people, last question. Take a look at this one. A current of 2 ampere is passed through a cell of resistance 75 ohms for 2 minutes. How much heat energy is produced? How much charge is passed through the resistance? Last question, guys. Last question. Relax yourself and do this. That's all. Alright, your options are 20,000 joules and 2000 coulomb, 3600 joules and 1120 coulomb, 36,000 joules and 240 coulomb, or 5,000 joules and 250 coulomb. Go ahead, guys. Let's go. chill Dev, nothing like that. It's okay. Like I told you, it's alright. So, but we can find through power is equal to VI, then directly proportional to I. So current or power should be more, right? Yeah, Sanjay. You can turn it. You can do it in terms of current also. You can find out the current also. That is also absolutely correct. You can do it in terms of that also. You can do it any way you want. I did it in terms of resistance. You can do it in terms of current also. Absolutely. But again, you have to remember that because it's in series, you have to calculate. The current is going to be the same. If you talk about it in series, because they're both connected in series, current is going to be the same. So it will not make much difference. You will have to then instead of V, you have to substitute Ohm's law. So it will be I square R again. So you'll have to go to I square R wala formula. P is equal to I square R. Not, you can't directly write as VI, you'll have to write as I square R. Because again, you do not know, because the current is going to be the same, so you can't use that formula. Alright? Anyways. Anything else, guys? All the best, Keith. All the best. Do well. It's all right. No worries. So yeah, people, that's it. 40 of you guys for the last question. Absolutely wonderful. All the last two questions were a little bumpy, right? I understand that. But the last question rocked it, people. Exactly correct. How much heat energy is produced? Heat energy is equal to I squared RT. So I know the current is 2 amperes. So 2 square into resistance is 75 into time taken is 2 minutes. So convert that to seconds. 2 minutes into 60 seconds. So that's 120 seconds. So into 120, if you multiply this, you'll get it as 36,000 joules. So heat energy is 36,000 joules. So how much charge is passing through the resistance? So that is basically Q. So you know that current is equal to rate of flow of charge. So it's Q by T. So what is Q? Q is equal to I into T. Current is equal to 2 amperes. Time is equal to 120 seconds to 4. So 240 coulomb would be the answer. That is it, people. That is all. That is it for today. Done. That's it. No more. Here is your final leaderboard as well, people. Take a look at this one. Absolutely wonderful. Until the end, all of these guys, like fought tooth and nail and finally got it. Prasoon is the winner for today. Congratulations, Prasoon. Absolutely wonderful. Ended the new year with a bang. Absolutely wonderful, buddy. Keep it up. Keep up the good work. Followed by Nijam in the second. High five. Absolutely wonderful. Now, Sanchit, superbly well done. Congratulations. Third, I believe, is I'm not really sure. I can't read the name properly. Fourth is Crazy Boy. Then it's Rudraksh. Then it's Keshav, Saina, Aniket, and Satish. Well done, guys. Well done. I'll be putting up it. Putting it up in the story later. So that is pretty much it. Now, guys, if you have any doubts or questions, you can ask me right now. This is your time. Thanks a lot, Devita. Thank you. So that is pretty much it, people. I know the last two questions, ate up a lot of energy, but yes, it had to be done. It was very, very important. Very important questions. That's why I had to say it. Anyways, Prasoot, congratulations. Happy New Year, people. Once again, Happy New Year to all of you guys. So that is pretty much it. So these are some of the questions that I got in the previous session. So I'll just quickly answer these questions as well. The first doubt was this. So how is the positive and negative terminal is maintained by a cell? So guys, you have to remember that, if you have a dry cell, like the normal battery that you have, like in this one and all, these are the normal batteries that you have. These are called as dry cells. So here you have something called as a carbon rod, which act as the cathode, and the anode is the zinc plate. So at the bottom part, wherever is the negative terminal, that is actually a zinc plate. Inside of this, you will have an electrolytic solution. Basically, mostly magnesium oxide is what is used. Magnesium oxide, or sometimes it's aluminum oxides as well. Those are the electrolytic solutions. So you have the cathode, which is the positive terminal, and the anode, which is nothing but the zinc plate, which will be the negative terminal. So that's how the negative and positive terminals are maintained. Now, in the case of voltaic cell, it'll be like electrolytic cell, or if we talk about galvanic cell, it'll be a little different, because over there, whichever side you're connected to the positive terminal, that will act like the positive terminal in that galvanic cell or the voltaic cell, and whichever is connected to the negative terminal, that will be the negative terminal, because again, it's an electrolytic solution. But again, the kind of electrodes that you use matter. For example, if you talk about zinc and copper would be connected to the positive terminal, and zinc will be connected to the negative terminal. So that is also important. The kind of material that you use is important, and to which terminal of the battery are you connecting to, that also matters. All right, so that is the answer for this question. Very good question again, Rupa. Sneha also had a question. This was the question. This is the question, sir. A given length of the wire is doubled of itself, and the process repeated again. What would happen to the resistance? It's a very simple question. So first of all, the new resistance, first of all, they're doubling it. So R dash is 2R. Alright, sorry, it's a length. No, length is getting doubled. So it's a very simple question. I think we've answered this question several times in the class already. So length is getting doubled. It'll become 2L. So new length is 2L. Now again they're doubling it. They're repeating the process once again. So what will be the actual length? So L dash will be 2L into 2L, which will be nothing but 4L. This is the actual length now, because they are doubling the length. So what they are doing is basically, this thing. They're doubling the length, and again they're doubling it. So what will happen to the length now? The new length will be 4L. Now again, what will happen to the area then? Area will become A by 4, because again the new area will be A by 4. Again, why? Because again volume is equal to area into length. So A into L is equal to A dash into L dash. L dash is nothing but 4L. So LL gets cancelled. So A dash is equal to A by 4. So area, the new area is A by 4. 4 times, or 1 by 4 is the actual area. Now put it in the equation. R is equal to rho L by A. So rho into L is what? L is 4L, and area is A by 4. So 4 will go to the numerator. So R is equal to rho into 4 is 16. So L by A into 16 is what you're going to get. This is R dash. We'll take it as R dash. So what is R? R is nothing but the actual resistance. So R dash is equal to R into 1 by 16. So what will happen to the resistance? It will become 1 by 16th of the original resistance. Alright, so that is the answer, guys. That is the sorry, not 1 by 16, it will be into 16. No, the resistance will become 16 times greater. It will become more 16 times, not 1 by 16, it will be 16 into R. 16 into R. So the original resistance, now actual resistance will become 16 times the original resistance. That's all. That is the case. That is the answer for this question. So that is pretty much it. So yes, again, that is all I had to say. Once again, thank you for joining. Once again, a very, very happy new year. I really hope that you guys enjoyed today's session. I know it was really, really long. There was a lot of questions that I had to take a little bit time on. So yes, people, once again, I wish you guys all a very happy new year and all the best for your board exams and your pre-boards. Do really, really well. Watch the recordings of the previous session. If you have any doubts with regard to EMF or any concept that you do not understand, go through all the chapters of all the things of current electricity. I've done it in detail, especially if you go to that EMF wala thing, no, you will find it very, very easy to understand. So make sure that you watch that video for all of those who are confused about EMF. And that is pretty much it. Once again, thank you for joining. I'll see you guys soon. Thank you once again, people, for joining today's session. Once again, a very, very happy new year to all of you guys out there. Once again, thanks a lot for all the likes and support. I'll see you guys in the next one. Sure, there with one day when I decide to travel the whole of India, which will happen soon, then for sure I'll visit all of my students' houses for sure. So once again, thank you for joining, guys. I'll see you soon. So minimum of PYCs should solve. Yeah, sure. Quite sure. You have to solve the past year's question paper for sure. Past year's paper, at least the past 10 years you have to solve. Alright, past 10 years you have to solve. That is very, very important. Past 10 years is very, very important. Alright guys, anyways, thank you for joining, guys. Once again, thank you. Do not forget to like, share and subscribe to be a part of the squad. Thank you for joining. I'll see you guys soon. Take care of yourselves, stay safe, and bye bye guys. Take care. Bye bye. See you all guys. Enjoy yourself. Happy New Year.